students, welcome to my class. Today we are going to start the discussion on pulley. What is a pulley? Pulley is a disc which is made of metal or wood. Okay, and it has a grooved rim. A rope or a string is passed through it and it rotates. The disc rotates about a fixed axle, and the axle is also fixed rigidly onto something. Let it be wall or wood or anything. And we can do our work very easily using a pulley. That means you can lift something heavier using a pulley. You might have seen people taking out water from a well using a pulley. In that case, you might have seen that the pulley is actually fixed over the well onto something. Okay, and people, they attach the container with a rope, and that rope goes through the pulley, and people used to pull the container out very easily. Okay, so we are going to discuss the functionality about the pulley, why and how it helps us to do our work. Okay, have a look on the diagram that is given on the screen, and you can come to understand the construction of a pulley, and you can very well see that it is fixed to something. Let it be a roof or wall or anywhere. A single pulley can be used in two different ways. First is fixed pulley. See, the name itself indicates that the pulley is fixed. That means we need to keep the axis of rotation stationary, and the frame is actually fixed. It doesn't move. Okay, and the second one is movable pulley. See, the name itself indicates that the frame moves or the pulley moves. That means its axis of rotation changes time and again. That means in that case the pulley is movable. So let us now discuss about single fixed pulley. Okay, students, a pulley which has its axis of rotation stationary in position is called a fixed pulley. So let us now discuss about the single fixed pulley with a diagram. Okay, students, as you can see in the diagram, the axle of the pulley is fixed to a rigid support, and an inextensible strong string of negligible mass passes around the grooved rim of the pulley. One end of the string is connected to the load, which is denoted by L, while the effort, which is denoted by E, is applied at the other end of the string. Other end means here is the free end. This end of the string is free. Both the load and the effort act downwards. You can see in the diagram, the load and effort, they are acting in the downward direction. On pulling the string downwards by the effort, the pulley rotates and the load moves up. The tension throughout the string is T. Students, we know that whenever a string is stretched, tension acts upon it. What is tension? Tension is a force along the length of a medium, especially a force carried by a flexible medium such as a rope or cable. So in this case as well, as the load is attached to the end of the string and the load is towards the downward direction, an equal amount of force, which is called the tension, is acting in the upward direction. Okay, but it is also true that if the tension throughout the string is not same, then even if the pulley doesn't move, string tends to move. You need to remember that in such cases, in case of a single fixed pulley, the tension throughout the string has to be same. Okay, and it is always in the upward direction. This type of pulley is used for lifting a small load. For example, we use single fixed pulley to lift a water bucket from the well. Okay, so what makes the pulley rotate? It is the friction between the string and surface of the rim of the pulley that helps the pulley to rotate when the string is pulled downwards. Okay, students, let us now discuss about the mechanical advantage, velocity ratio and efficiency of a single fixed pulley. Okay, see, if we neglect the mass of string and friction at the axle or in the pulley bearings, if we neglect this, okay, then in ideal condition what is happening that the load is equal to tension. Okay, and when pulley is not rotating, then effort is equal to tension. Where pulley is not rotating. Okay, so from these two equations we can come to the conclusion that effort will be equal to load. Okay, so if we neglect the mass of string and friction at the axle or in the pulley bearings, then effort will be equal to load. Okay, so in case of a single fixed pulley, the effort required to lift a load would be equal to the load itself, isn't it? Because load is equal to effort, that means we need equal amount of effort to lift a load. So as you can see in the diagram, for example, if the load is of 10 kilogram force, or that is 98 Newton, then effort we need to pull this load, that will be equal to 98 Newton. So the mechanical advantage would be equal to load by effort. Okay, and we know that they are equal to the tension that is acting in the opposite direction. So as per the tension which is acting in the opposite direction, we get 1. So mechanical advantage of the single fixed pulley is equal to 1. So this is when the pulley is in its stable position. Okay, so what would happen if the pulley moves or we start doing some kind of work? That means we try to lift the load. That means in that case, if we put some effort, okay, in the downward direction, which direction? Downward direction. Okay, and for a distance of d, then the load, it moves in the upward direction, okay, for the same distance, that is d. That means displacement of effort is equal to d and displacement of load is also equal to d. So what to do with the velocity ratio? That is dE by dl, as we have discussed in our earlier classes. So that would be equal to d by d or 1. Okay, so in case of single fixed pulley, the velocity ratio is also equal to 1. So let us now discuss what is happening with the efficiency. Okay, efficiency, that is eta, as we have discussed in our earlier classes, the ratio of mechanical advantage and velocity ratio, which we have found out to be 1. So the efficiency is equal to 1, or we can say efficiency would be 100%. But practically friction lies between the string and the pulley. So the effort that we need to lift the load will always be greater than that of the load, because friction is acting in the opposite direction. So we need more force to lift the load. So the mechanical advantage of the single fixed pulley is always less than 1. Mechanical advantage is always less than 1. But velocity ratio equal to 1. So that is why the efficiency of a single fixed pulley is always less than 100%. Because mechanical advantage is less than 1. So the efficiency is always less than 1, that is less than 100%. So efficiency is also less than 100%. You need to remember. As there is no gain in mechanical advantage and velocity ratio when we use single fixed pulley, then why do we use single fixed pulley? A single fixed pulley is used to change the direction of application of force. Okay, you need to remember. So let us take the example of pulling a bucket of water from a well. If there is no pulley, what we do? We pull the bucket of water in the upward direction like this, using the same effort. But when we use the pulley and pull the bucket of water from the well in the downward direction, so the effort is now put in a convenient way. That is the reason we use the single fixed pulley. Okay? Students, let us now discuss about a single movable pulley. A pulley whose axis of rotation is movable or it is not fixed in position is called a movable pulley. So let us now discuss about the functionalities of a movable pulley with a diagram. Okay? So students, as you can see in the diagram, a single movable pulley is suspended by passing an inextensible string of negligible mass around its grooved rim. So in this case, the frame of the pulley is not fixed to a rigid support. Okay, the load L which is to be raised is suspended from its axle. One end of the string is tied to the hook edge at a rigid support. So one end of the string that is actually going through the pulley is being attached to a hook which is fixed to the rigid support. The effort E is applied at its free end. So as you can see in the diagram, one end of the string is attached to the hook which is fixed to the rigid support and the other end is free and the effort is being put at its free end. Okay? So what about tension? As you have already discussed, tension is acting in the opposite direction of load. That means in this case, the tension of the string is acting in the upward direction because the load is acting in the downward direction. Okay. So in this case, tension acts in both sides of the pulley. In one side, it is acting towards the hook to which one end of the string is being attached, and in another side it is acting in the upward direction in the direction of effort. Okay? So students, let us now discuss about mechanical advantage, velocity ratio and efficiency of a single movable pulley. So if we neglect the friction in the pulling bearings or at the axle and the weight of string and pulley, we neglect it. Okay? That means these are negligible. Then how the load is being balanced? Because the tension is acting at both sides of the string, so the load can be balanced if it is equal to the sum of the tension forces those are acting in the upward direction. That is why in this case load is equal to T plus T. These two tensile forces are acting in the upward direction which is balancing the load which is acting in the downward direction. That's why it is 2T. So in this case the effort equal to T. So what would be the mechanical advantage? That is load by effort, or 2T by T, that is 2. Okay. So mechanical advantage of a single movable pulley would be 2. So what is happening with the velocity ratio? This is when the pulley is in balanced condition. Now if we put some kind of effort and there would be displacement of the string. So what is happening over here? So if the effort is put in the free end of the string and it moves a distance d, okay, this is because of effort. Then the load moves a distance d by 2, because when the effort is put, the two segments those are at two sides of the pulley, they move a distance of d by 2. That means whenever the displacement due to effort is d, then displacement of load will be d by 2. So what would be the velocity ratio then? That is dE by dL or d by d divided by 2, that is d into 2 by d or 2. So velocity ratio of a single movable pulley is also 2. So what happens with the efficiency? So efficiency theta would be mechanical advantage divided by velocity ratio, that is 2 by 2, that is 1. Or we can say the efficiency would be 100%. Okay, students, in case of actual single movable pulley, what happens because of friction and weight of string and pulley, we need more effort to lift up a load. And the effort we need would be more than L by 2. That is why mechanical advantage is always less than 2. Okay. Mechanical advantage is less than 2, but the velocity ratio, it remains constant. Okay. So the efficiency is always less than 100%. Okay. You need to remember this. This is for actual single movable pulley. Okay. Students, we have discussed that it is very inconvenient to use effort in the upward direction. Mechanical advantage of using single movable pulley is 2. Fine. But it is inconvenient to put effort in the upward direction. So what we can do, we can use the movable pulley with the fixed pulley so that the direction of putting effort can be changed. Okay, as we have discussed, in case of fixed pulley, the direction is in the downward direction and a person can use his own weight as effort, which is very convenient. As you can see in the diagram, load is attached to the frame or the axle of the movable pulley. The string which is passing through the single movable pulley is now going through the single fixed pulley, and the free end is now in the downward direction where we put the effort. Okay, so now we have changed the direction of effort, which is previously in the upward direction through a single movable pulley. Now in the downward direction when we connect our single fixed pulley to the string. Okay, so in this way we can change the direction. What happens to the mechanical advantage and velocity ratio for such arrangements? Mechanical advantage remains 2. The velocity ratio also remains 2. That means the effort is L by 2. So as you can see in the diagram, if a load is of 98 Newton, we need to put the effort, that is 98 by 2 or 49 Newton. Okay, and there would be a tension force acting in the opposite direction of effort in the string. That would be equal to 49 Newton. So see, by using such an arrangement, we apply the effort which is half of the load. Isn't it great? Students, let us now discuss the comparison between a single fixed pulley and a single movable pulley. Okay? So students, in case of single fixed pulley, it is fixed to a rigid support, but single movable pulley is not fixed to a rigid support. The ideal mechanical advantage of single fixed pulley is 1, but in case of single movable pulley, the mechanical advantage is 2. When you think about velocity ratio, it is 1 for the single fixed pulley, but 2 for the single movable pulley. The weight of pulley itself does not affect its mechanical advantage in case of single fixed pulley, but the weight of pulley itself reduces the mechanical advantage of a single movable pulley. Single movable pulley is used to change the direction of effort from upwards to downwards, but we have discussed, but the single movable pulley is used as a force multiplier. In case of single fixed pulley, the load moves in a direction opposite to that of the effort, but in case of single movable pulley, the load moves in the direction of the effort. In case of single fixed pulley, the axis of rotation does not move in space, But in case of single movable pulley, the axis of rotation also moves. Okay? Students, today we have discussed about some of the concepts on pulley. I hope you have understood everything clearly. Please go through your books. Just go through the concept that you have learned today. If you face any kind of difficulties again, then watch the video again. You need to revise the concepts after you learn it. Okay? So keep revising, keep practicing, and most importantly, keep smiling.